So the next statement is silt particles can be seen by naked eyes. So is this statement true or false? This statement is absolutely false. Silt is a fine-grained soil. Silt is a fine-grained soil having particle size between 0.002 mm to 0.075 mm. Alright, silt is a fine-grained soil having particle size between 0.002 mm to 0.075 mm, and the particles are not visible to naked eyes. Alright, the particles of the silt, they are not visible to the naked eyes. Alright, so this statement is absolutely false. Silt particles can be seen. No, they cannot be seen by naked eyes. Their particle size is very small, very small. It lies somewhere between 0.002 mm to 0.075 mm. Alright. Clay is even finer, and that can be seen by very powerful magnification. Alright. The particles of clay, because clay size is even smaller, so those particles can be seen under very powerful magnification. And so for that matter, here this statement that the silt particles can be seen by naked eyes, no, it's absolutely not correct, it's false. Moving on to the next question. All right, the intensity of the statement is the intensity of chemical weathering of rocks is maximum in cold climates. All right, we have to see whether this statement is true or false. The intensity of chemical weathering is maximum in cold climates. No, it's false. This statement is absolutely false, because the intensity of chemical weathering is generally maximum in hot and wet climates, and not in cold climates. All right, because chemical weathering process such as oxidation, because we know that during the chemical this weathering or the chemical decomposition of rocks, certain processes take place, such as that of oxidation, hydration, carbonation, solution hydrolysis, etc. So the chemical weathering processes, they require water, and they occur faster at higher temperatures. All right, at higher temperatures. So the cold climates slow down chemical reactions. All right, cold climates slow down the chemical reactions. So chemical weathering is much less intense. Chemical weathering is much less intense. So this statement is absolutely false. All right, so in cold regions we can say that the physical or the mechanical weathering such as freeze thaw action is often more important. So the process of physical disintegration is more important in cold regions, because the actions such as freeze thaw action is very important, and that is the process of the physical disintegration or the mechanical weathering of the rocks, but not the chemical weathering or the chemical decomposition. So in general, we can say that the intensity of chemical weathering is generally maximum in hot and wet climates and not the cold climates. So this statement, the intensity of chemical weathering of rocks is maximum in cold climates, is absolutely incorrect. False. Next question is, next statement is rather, slopes of cuts made in Louis are able to stand nearly vertical. All right, we know that Louis is a silt deposit made by wind, and this Louis, this is a fine-grained soil. This is wind deposited sediment. We know that, mostly silt. We know that, and it's highly porous and has enough cohesion to maintain nearly vertical slopes. It has enough cohesion to maintain nearly vertical slopes when cut. All right. This is a very well-known characteristics of Louis deposits, which is why roads, trenches, and river valleys cut into Louis often have steep, almost vertical walls. All right. So slopes of cuts made in Louis are able to stand nearly vertically. This statement is absolutely correct. All right. Because Louis is a fine-grained soil, it's a wind deposited sediment, mostly silt, that is highly porous and has enough cohesion to maintain nearly vertical slopes when cut. And this is a very well-known characteristics of Louis deposits. That's why roads, trenches, and river valleys, etc., which are cut into loamy, often have steep, almost vertical walls. All right, moving on to the next statement. Next statement is soil transported by wind are deposited in a sorted state. We know that all those deposits of soil which are transported by wind or wherein the agency of transportation is wind, they are known as aeolian deposits. All right, and we have to say whether this statement is correct or not. We know that this is a very effective sorting agent. We must note that. Wind is a very effective sorting agent, and during transportation, it tends to carry and deposit particles according to their size and weight. All right. Wind is a very effective sorting agent, and during transportation of these soils, it tends to carry and deposit particles according to their size and according to their weight. And so we can say that in general, these aeolian deposits, all those deposits of soils which are transported by wind, they are generally well sorted. We can also say that the sand dunes also, they come under the category of well sorted sand. So this statement that the soil transported by wind are deposited in a sorted state is absolutely correct. All right, next statement. The black cotton soil of India are residual soil deposits. We have to say whether this statement is true or false. Black cotton soils of India, they're also known as the regur deposits or the regur soils. These are generally considered residual soils because they are formed in place from the weathering of the basaltic lava rocks, especially Deccan Trap. All right. So these black cotton soils of India, they are residual soil deposits. This statement is absolutely correct. Yes, the black cotton soils of India are residual soils. They are known as regular soils, and they are formed from the weathering of the basaltic lava rocks, especially the Deccan traps. All right, and coming to the next question, it's about the same thing. Black cotton soils. The statement is black cotton soils cover about 10% of the land area in India. Is this statement true or false? Black cotton soils cover about 10% of the land area in India. No, this statement is false. This statement is false because the black cotton soils or the regular soils, they cover about 16% of India's total land area. All right. So the statement black cotton soils cover about 10% of the land area in India is absolutely not correct because they cover generally about more than 10%. They cover about 16% of the total land area of India. All right. This is not the last statement. We have two more. Next statement is given a choice, engineers prefer coarse grained soils to fine grained soils for most civil engineering works. Is this statement true or false? This statement is absolutely correct. If given a choice, engineers would definitely prefer coarse grained soils to fine grained soils for most of the civil engineering works. Why? Because engineers usually prefer coarse grained soils like sand and gravel over fine grained soils like silt and clay because they have higher strength and stability. This must be noted that the coarse grained soils, they have higher strength and stability. They show better drainage than fine grained soils. They show better drainage because there is less water retention, and they undergo less shrink and swell volume changes. And one more characteristic, they are easier to compact and work with. On the other hand, fine-grained soils such as silt and clay, they often hold water, so they don't have better drainage characteristics. They become weak when wet and they show more settlement and deformation. All right. So if given a choice, engineers definitely prefer coarse-grained soils to fine-grained soils for most of civil engineering works. All right. So this statement is absolutely correct. All right. Moving further. Next statement is mica is a clay mineral. Statement is mica is a clay mineral. Is this statement true or false? This statement is absolutely false. Mica is not a clay mineral. It's a group of sheet silicate minerals. It's a group of sheet silicate minerals known for their perfect cleavage, allowing them to split into thin flexible sheets. All right, and the clay minerals are much finer and they form different structures. All right, so this mica is not a clay mineral. It's a group of sheet silicate minerals known for their perfect cleavage, allowing them to split into thin flexible sheets. Thin flexible sheets. All right, so mica is not a clay mineral. So this statement is absolutely false. The last statement that we have to analyze for its authenticity is rock dust particles, even of clay size, are non-plastic. Is this statement true or false? Rock dust particles, even when they are of clay size, they are not necessarily plastic, because plasticity is a characteristic. It's not just about the grain size, all right? It depends on mineral composition. This plasticity feature, this is not mere dependent on the grain size. It rather depends on the mineral composition. Mineral composition. Only certain clay minerals like montmorillonite, illite, and kaolinite, they only show this plasticity characteristics. All right. So we can say that rock dust particles, even of clay size, they are non-plastic. It's true. All right. If the particles are just finely ground rock fragments or rock floor, they remain non-plastic even if they are clay sized. So this feature of plasticity, this is non-dependent, or this is not just about the grain size. Rather, this depends on some other thing, that is the mineral composition. Only certain specific clay minerals like kaolinite, or howsoever you may like to pronounce it, illite and montmorillonite, they only show the plastic behavior when wet. So even if the particles are just finely ground rock fragments or the rock floor, they remain non-plastic. They completely remain non-plastic even if they are of the size of the clay. All right. So this statement that the rock dust particles, even of clay size, are non-plastic, this is absolutely correct. Moving further to question number 11. Question number 11 says, dash can be defined as a compact, semi-hard to hard mass of natural material composed of one or more minerals. All right. We have to say dash can be defined as a compact, semi-hard to hard mass of natural material composed of one or more minerals. The answer is rock. Rock can be defined as a compact, semi-hard to hard mass of natural material composed of one or more minerals. We also know it by definition, rocks, as a natural aggregate of mineral particles which are bonded by strong and permanent cohesive forces. Strong and permanent cohesive forces. So rocks can also be defined as a natural aggregate of mineral particles bonded by strong and permanent cohesive forces, or it can also be defined as a compact, semi-hard to hard mass of natural materials which is composed of one or more than one minerals. Alright, so the answer is rock. Next question. We move on to question number 12. So question number 12 is a natural inorganic substance of definite structure and chemical composition is known as. Alright, a natural inorganic substance of a definite structure and chemical composition is known as mineral. And this is what rocks are formed of, and subsequently the soils. Because soils are formed from the either physical disintegration or the chemical disintegration of, or the chemical decomposition or the chemical weathering of the rocks. Alright. So the answer is mineral. A natural inorganic substance of definite structure and chemical composition is known as mineral. Alright. Moving further to question number 13. Alright. From foundation engineering interest, which two physical properties of minerals are important? Crystal form and color, hardness and cleavage luster, fracture and specific gravity, or specific gravity and hardness. Alright, we have to tell the correct answer from foundation engineering perspective or interest. Which two physical properties of minerals are important? Alright, the two properties that are important from the foundation engineering perspective is specific gravity and hardness. Alright, so answer D is the correct answer. Option D is the correct answer. Alright, from foundation engineering interest, the two physical properties of minerals which are important are specific gravity and hardness. Alright, so this is the correct answer, because we know that some of the very important physical properties of mineral, they are crystal form, color, hardness, cleavage, luster, fracture, and specific gravity. But out of all these physical properties, those which are important from the foundation engineering perspective, they are specific gravity and hardness. All right, moving further to the next question. Question number 14, it is the specific gravity of the most rock and soil taking minerals varies from. All right, question is the specific gravity of most rock and soil taking minerals varies from. It varies from, I'll write it here, 2.50, it's for some feldspars, and 2.65, it's for quartz, to 3.5, this may be for augite or olivine, all right. So the specific gravity of most rock and soil taking minerals varies from 2.50 to 3.5, whereas 2.50 is the specific gravity for certain feldspars, 2.65 is for quartz, and to 3.5, which may be for augite or olivine. We may also note that gypsum, it has a smaller value of a specific gravity of 2.3, and salt, NaCl, sodium chloride, it has a specific gravity of 2.1. All right. It may also be noted that certain iron minerals have even higher value of specific gravity. For example, if we take magnetite, it has a specific gravity of 5.2. All right. So the answer is the specific gravity of the most rock and soil taking minerals varies from to 5.2. That is 2.50 is from for some feldspars and 5.2 is for one of the most important iron mineral, that is magnetite. It has the higher specific gravity of 5.2. We also learned in between the specific gravity of certain other minerals. All right. Moving on to the next question. We have question number 15 now. All right. The hardness of a mineral, symbol H, is expressed by its number in. The hardness of a mineral is expressed by its number in Mohs scale of hardness. All right. So the hardness of a mineral, we commonly categorize it by the symbol H. It is expressed by its number in Mohs scale of hardness. I'll tell you some examples. For example, if I make a table, it's standard mineral. It's the hardness value H. All right. For talc, it is 1 because it will mark cloth talc. All right. Next, if I go to gypsum, its hardness value is 2 because it can be scratched by a fingernail. Can be scratched by a fingernail. All right. By a fingernail. So on and so forth. For example, if I take quartz, on Mohs scale of hardness, its number is 7 because Mohs scale of hardness determines the hardness of minerals. All right. On Mohs scale, quartz has been given the number 7 because it cannot be scratched by a steel file. Cannot be scratched even by a steel file. Quartz. All right. So this was something about the hardness of the minerals, represented by the symbol H and expressed by its certain number on Mohs scale of hardness, which is a representation of the degree of hardness of certain rock forming minerals. All right. And let us take the best example, diamond. On Mohs scale of hardness, diamond has been given number of 10. H is 10 because it will scratch any substance except other diamonds. All right. It will scratch any substance except other diamonds. The hardest material known, diamond. All right. So this was about the degree of hardness, represented by symbol H and expressed by a certain number on Mohs scale of hardness. Moving on to next question. We have question number 16. And the question number 16 says state whether true or false. All right. We have to state whether this statement is true or it is false. The statement is leaching is the process whereby water soluble parts, calcium carbonate, are dissolved and washed out from the soil by rainfall, percolating water, subsurface flow, or other water. This statement is absolutely true. All right. Leaching is also one of the processes which happen during the chemical weathering or the chemical decomposition of rocks. All right. So leaching is also one of the process, and leaching is a process whereby water soluble parts such as calcium carbonate. They are dissolved and washed out from the soil by rainfall or percolating water or subsurface flow or maybe any other water. So this is the process of leaching, which is very important process which occurs during the chemical weathering or the chemical decomposition of the rocks. And we also know that fine grained soils get formed during these processes, the chemical weathering or the chemical decomposition. All right, moving further to the next question. Please bear with me, my throat is not well today. All right, next question, question number 17. Soils deposited by winds are known as, I think we already know that all those types of soils which are deposited by winds, they are known as aeolian deposits. All right, soils deposited by wind are known as aeolian deposits. All right, and we also learned before that the particles size of such soils depend upon the velocity of the wind, and the finer particles are carried away from the place of the formation. All right, so this was about all those soil deposits wherein the agency of transportation happens to be winds. So soils deposited by winds are known as aeolian deposits. All right. All right, silt. Next question, question number 18. Question number 18 is silt deposit made by wind is known as, a deposit of silt which is made by wind, it's known as Louis. All right, so Louis, you can pronounce it as Louis or Louis or howsoever you may like to pronounce it. So Louis or Louis, it is a silt deposit made by wind, and we also learned that it has low density and high compressibility, and bearing capacity of such soils is also very low. Also, and permeability, we also learned that the permeability is large in the vertical direction of these deposits. Silt deposits made by wind. Commonly general term for them is Lewis. Permeability is large in vertical direction. We are learning the subject of geotechnical engineering from these multiple choice questions or the one-line answers. Next question, question number 19. It is Lewis deposits have low density, high compressibility, low bearing capacity, large permeability in the vertical direction, or all of the above. We know that the correct answer is all of the above because we learned that these Lewis deposits, they have definitely low density, they have high compressibility, low bearing capacity, and they have quite large permeability in the vertical direction. So the correct answer is all of the above. All right. Next question, question number 20. Dash is a general term used for the deposits of soil made by glaciers directly or indirectly. All right, drift. Drift is a general term used for the deposits made by glaciers either directly or indirectly. And those made by melting of glaciers directly, those deposits of soil are known as till. Next question. Oh, this is the next question. All right, deposits directly made by melting of glaciers, they're called as till. Next one. At the terminus, a melting glacier drops the material in the form of ridges. That is known as drift, till, terminal moraine, or outwash. As already learned, that is known as terminal moraine. Alright, because during their advancement, glaciers go on depositing and transporting soils, and at the terminus, a melting glacier drops the material in the form of ridges, and which is known as terminal moraine. Alright, question number 23. The land which was once covered by glaciers and on which till has now been deposited after melting of the glacier, that is called ground moraine. We have already learned it. That is known as ground moraine. Alright, so the ground moraine is a land which was once covered by the glaciers and on which now till has been deposited after melting of the glacier. That land is known as the ground moraine. So this was about question number 23. Moving on to question number 24. Question number 24 says the soil carried by the melting water from the front of the glacier is termed as, it's termed as outwash. All right. So the soil carried by the melting water from the front of the glacier, that is known as the outwash. All right, students, moving on to the next question. Question number 25. All right. Question number 25 says deposits of soil which are transported and moved by glaciers and subsequently deposited by streams of melting water and have stratification, they are known as, we have to give us a correct term for all those deposits of soil which are transported and moved by glaciers and subsequently deposited by streams of melting water and they have stratification. They are known as already learned before, they're known as glaciofluvial deposits. All right, so the glaciofluvial deposits are formed by glaciers. The material is moved by glaciers and subsequently deposited by streams of melting water. So these deposits definitely have stratification, and such deposits of soil are known as glaciofluvial deposits. All right, moving on to the next question, question number 26. All right, question number 26 says some characteristics of bentonite are, we have to choose the correct answer. 1. It has high percentage of mineral montmorillonite. It is formed from decomposition of volcanic ash. It is highly water absorbent and has high shrinkage and swelling characteristics, or all of the above. We know that all these are characteristics of this bentonite. It is a type of a clay. It has to be noted that bentonite, it is a type of clay with very high percentage of clay mineral montmorillonite. It has a very higher percentage of clay mineral montmorillonite, and it is highly plastic clay and it results from the decomposition of volcanic ash. It results from the decomposition of volcanic ash. Alright, and it's highly water absorbent and has high shrinkage and swelling characteristics. So all the options are correct. So the correct one among all of them will be all of the above. Alright, so some characteristics of bentonite are, it has definitely high percentage of the clay mineral montmorillonite. It is formed from decomposition of volcanic ash. It's true, it is highly water absorbent and has high shrinkage and swelling characteristics. Alright, going to the next question, question number 27. Alright, we have to match the following. We, on the one hand, we have been given the type of the soil, and corresponding to it is particle size is given. All right, so we have to go on matching the type of soils with their corresponding particle sizes. First one is clay. We know that clay consists of microscopic and submicroscopic particles which is derived from the chemical decomposition of rocks, and the particle size is less than 2 micron or 0.002 mm. Alright, clay, it consists of microscopic and submicroscopic particles which are derived from the chemical decomposition of the rocks, and it contains definitely large quantity of clay minerals. Alright, and the particle size, it varies. It does not vary. It's generally less than 2 micron or less than 0.002 mm. Alright, next one, boulders. Boulders are rock fragments of large size, more than 300 mm in size. Next one, cobbles. Cobbles are large size particles in the range between 80 mm to 300 mm. Alright, next one, silt. Silt is a fine-grained soil with particle size between 0.002 mm to 0.075 mm. And as already learnt before, the particles are not visible to naked eyes. Alright. Size ranging from 0.002 mm to 0.075 mm. Next one is gravel. Alright. Gravel is the type of the coarse grained soil or the cohesionless soil, and the particle size ranges from 4.75 mm to 80 mm. Alright. Gravel. Alright. It's a type of the coarse grained soil or the cohesionless soil, wherein the particle size ranges somewhere between 4.75 mm to 80 mm. Next one, Lewis. Alright. Alright. And then we have sand. First we'll match the sand with its correct particle size. Alright. We know that sand is a coarse grained soil having particle size somewhere between 0.075 mm to 4.75 mm. It's there only. Sand, it's a coarse grained soil having particle size between 0.075 mm to 4.75 mm, and the particles are visible to naked eye. This must be noted. The particles of sand, they are visible to naked eye, wherein the particles in case of clay, they are not visible to naked eye, and the particles of silt, they are not visible to the naked eye, and the particles of clay, they are even finer, they are not visible to the naked eye. We can only see them under very powerful magnification. All right, so the last one left is this Lewis. Particle size, it ranges somewhere between 0.01 to 0.05 mm. All right, as we know, Lewis, it's a wind-blown deposit of silt, and it's generally of uniform gradation with the particle size ranging between 0.01 to 0.05 mm. And it's also to be noted that it consists of quartz and feldspar particles. Quartz and feldspar particles which is cemented with calcium carbonate or iron oxide. Calcium cemented with calcium carbonate or iron oxide particles in Lewis, which is a silt, wind-blown deposit of silt. And the point to be noted here is the particle size ranges between 0.01 to 0.05 mm. All right, so this was about the question number 27. Moving on to question number 28. Alright, so the question number 28 says, type of soil which contains gravel, sand and silt and in which particles are cemented by calcium carbonate is called conker, humus, loam or caliche. Alright, so we have to tell which is the correct option. Alright, conker. It is an impure form of limestone. Conker is impure form of limestone and it contains calcium carbonate mixed with some siliceous material. It contains calcium carbonate mixed with some siliceous material. This was about conker. Then humus, it's a dark brown. It's a dark brown organic amorphous earth of the topsoil, and it consists of partly decomposed vegetal matter. Partly decomposed vegetal matter. And this must also be noted that it's not suitable for engineering works. This humus, it's not suitable for engineering works because it consists of partly decomposed vegetal matter, all right, or the organic matter, you can say. Next one is loam. Loam, it is a mixture of sand, silt, and clay. And this term is generally used in agronomy, where the soil is well suited to tilling operations. This loam, the soil is quite suited to tilling operations. This term is generally used in agronomy, where the main interest is growing of plants. And this loam happens to be a good soil for that purpose because it contains or it consists of all of them: sand, silt, and clay. All right. So the last one is this one, caliche. It is a type of soil which contains gravel, sand, and silt. Loam contains sand, silt, and clay. Caliche contains gravel, sand, and silt, and the particles are cemented by calcium carbonate in caliche. It consists of gravel, sand, and silt, and the particles are cemented by calcium carbonate. All right. So I think this is our correct answer. Question was the type of soil which contains gravel, sand, and silt, and in which particles are cemented by calcium carbonate. That type of soil is known as caliche. All right. So this was question number 28. Moving on to question number 29. Question number 29 is type of soil which contains sand, silt, and clay and which is well suited to tilling operations is known as, I think we learned about it just a while ago, it's known as loam. All right. So let me introduce you to the other options as well. Hard pans. Hard pans are the type of soils that offer greater resistance to the penetration of certain drilling tools during soil exploration. All right. These soils are designated hard pans regardless of their particle size, and these are generally dense, well graded, cohesive aggregates of mineral particles. And hard pans do not disintegrate when submerged in water. These hard pans, they do not disintegrate when submerged in water, and they offer great resistance to the penetration of drilling tools during soil exploration. Dune sands, these are wind transported soils, and these are composed of relatively uniform particles of fine to medium sand. All right. Loam, we already know it's a mixture of sand, silt, and clay, and this term is generally used in agronomy. And the soil is well suited to tilling operations, which is our question and which is the answer. All right. Let me introduce you to the last option, diatomaceous earth. This diatoms, we know they are minute, unicellular, in which there is only one cell, unicellular marine organisms. All right, diatoms, these are the minute unicellular marine organisms. All right. And this diatomaceous earth, this is a fine light gray soft sedimentary deposit of the siliceous remains of skeletons of diatoms. All right, we came to know that the diatoms are the minute unicellular marine organisms. All right, and this diatomaceous earth, it is a fine light gray soft sedimentary deposit of the siliceous remains of the skeletons of diatoms. Alright, so this is diatomaceous earth. Moving on to question number 30. Alright, so the question number 30 is What is fine, light gray, soft sedimentary deposits of the siliceous remains of skeletons of diatoms known as? It is known as diatomaceous earth. Alright? It is known as diatomaceous earth. It's a fine, light gray, soft sedimentary deposits of the siliceous remains of the skeletons of the diatoms, and we know that the diatoms are the minute unicellular marine organisms. Alright, going further to question number 31. Question number 31 is special types of clays, alright, which deflocculate in still water and erode when exposed to low velocity water is known as? The answer is dispersive clays. Alright, so the dispersive clays, these are the special type of clays which deflocculate in still water, and such soils erode when they are exposed to low velocity water. Alright, so the answer is dispersive clays. Moving on to question number 32. Alright, I think we knew about that. We have learned just a while ago about this. Dark brown organic amorphous earth of the topsoil, which consists of partly decomposed vegetal matter and is not suitable to engineering works, is known as? It is known as humus. Humus. It's a dark brown organic amorphous earth of the topsoil, and it consists of partially or partly decomposed vegetal matter, and it's not suitable for engineering works. All right, next one, question number 33. All right, wind blown deposit of silt, which is generally of uniform gradation, which when wet becomes soft and compressible because of loss of cementing action, is known as? All right, I think we know the answer. It is known as Lewis. Alright, Lewis is a wind-blown deposit of silt, and it is generally of uniform gradation with the particle size ranging between 0.01 to 0.05 mm. And we also learned that it consists of the particles of quartz and feldspar, which is cemented with calcium carbonate or iron oxide. But when wet, it becomes soft and compressible because cementing action is lost. Alright. So Lewis is the correct answer to this question. When blown deposit of silt, which is generally of uniform gradation, which when wet becomes soft and compressible because of loss of the cementing action, it's known as Lewis. Next one, question number 34. Alright, question number 34 says, organic soil having fibrous aggregates of macroscopic and microscopic particles formed from vegetal matter under conditions of excess moisture, such as in swamps, is known as? Is it known as tuff, walled clays, till, or peat? Alright, we have to tell the answer. Tuff, till, warped clays, or peat? Answer is peat. Alright, so organic soil having fibrous aggregates of macroscopic and microscopic particles formed from vegetal matter under conditions of excess moisture, such as in swamps, it is known as peat. Alright, it is an organic soil having fibrous aggregates of macroscopic and microscopic particles. It's formed from vegetal matter under conditions of excess moisture, such as in swamps, and it's highly compressible. It is highly compressible and is not suitable for foundations. So this is known as peat. Let me introduce you to the other option, tuff. It is a fine grained soil. It is a fine grained soil which is composed of very small particles ejected from volcanoes during explosion. during their explosion and deposited by wind or water. Alright, so tuff, it's a fine grained soil composed of very small particles ejected from volcanoes during their explosion and subsequently deposited by either wind or water. Warped clays. These are sedimentary deposits consisting of alternate thin layers of silt and clay, and the thickness of each layer seldom exceeds 1 centimeter. These clays are the results of deposition in lakes during periods of alternately high and low waters. Alright, so this was about the warped clays, which are the sedimentary deposits consisting of alternate thin layers of silt and clay, and so much so that the thickness of each layer seldom exceeds 1 centimeter. Alright, till you already know, and peat was the answer to the question. Peat is organic soil having fibrous aggregates of macroscopic and microscopic particles formed from vegetable matter under conditions of excess moisture such as in swamps. It's known as peat. Alright, moving further to the last question of this video. Alright, question number 35. Question number 35 says, sedimentary deposits consisting of alternate thin layers of silt and clay. These clays are the results of deposition in lakes during periods of alternately high and low waters these are known as warped clays. Warped clays are the sedimentary deposits consisting of alternate thin layers of silt and clay. We also noted that the thickness of each layer seldom exceeds 1 centimeter, and these clays are the results of deposition in lakes during the periods of alternately high and low waters. Alright, so the answer is warped clays. And with this, we come to the end of this video lecture. Thank you for watching.